This is a kind of a brief little thing here. I'm gonna close the door because Charles is beating on those balls. Charles, use a pickle fork if you need to. You know that little fork, pickle fork you back in there? Use that if you need to. I don't guess he calls it a pickle fork, but he was confused when I told him to use a pickle fork. All right, so this is a little bit of a, this is a sort of a short presentation. It's not going to be all that long, but it's going to give you some information about this. Now, everybody knows when you're looking at schematics, pretty much how to read a schematic. You know the power always comes in from the top, and the ground typically comes in from the bottom. And you notice this right here. This one here is a sort of a little thing where they had to loop the ground over and come in here because the AC compressor cycling switch, you see, is basically grounded. Whenever it grounds, it's got a little current limiting resistor there. If you just had straight voltage going out there, you'd burn something up. But if you got a resistor there to take care of that load, you got voltage here that's being measured right there. And then whenever this grounds, it basically shorts that voltage away, and this vehicle control module, this dynamics module, knows, this VCM, what's going on. Now that's kind of the way that goes. You got this switch right here is normally closed, that switch right there is normally open. You notice that? That's basically the way that operates over there. That's your compressor logic. We used to get really irritated whenever I was in the early 70s when I was working on cars, when we happened to see something that would say compressor logic or solid state. You don't know what's going in that box. And it was so bad sometimes that the even when I was at the Ford dealer in the 80s, the shop manual would say, put a known good part on there. If you ain't got a known good part, what are you going to do? That's what your manual would say. What I like to do is check the voltages and everything and see what the voltages are on a good car compared to a bad car. Now this right here is your blower control. There's your front blower switch. What we're going to do is walk through some schematics here and see how the difference is from one schematic to the next, because you need to be able to recognize this. Now you know that's what a fuse looks like, right? You know basically that's a switch. You know when you got a dotted box, remember this, I'm going to tell you this again because it's going to be on your electrical final. When you got a dotted box, that means you're not seeing the whole thing. We got a little line right there, you see that dotted line? That means both of those are in the same connector. I'm talking about a real skinny dotted line that's right there. That means they're in the same connector shell. And your HVAC control module, part of this is shown, part of that is shown, but the entire door motor is shown here, although they're not telling you what's in it and all that. But if you see a solid box, that means you're seeing the whole thing. If you're seeing see that right there, the blower switch, you're seeing the whole blower switch there, so they got a solid box around it, even though it's within that one right there. Now that's what a GM schematic. Let's look at the same schematic a little farther along. You got fuse, underhood fuse blocks, you're only seeing part of that. AC compressor clutch relay, you're seeing the whole relay, and that's a relay, remember that. What is this right here? Anybody know what that's for? What is that? Now you know this is the coil. Well, I'm sorry, this is the coil, excuse me. And what's that's what I should have asked for. That is a resistor, and what they did was they put a clamping resistor on there, like on the AC clutch. It's strong enough, got a big enough kick to it. Whenever you turn off that relay with the engine controller, let's say, and then when that little winding, whenever the voltage collapses, it creates a voltage spike, and you don't want that voltage spike to go screaming back into your ECM and damage the circuit down here. And so all these relays, even if you take one apart, you'll notice they got a little resistor that's wired parallel with the coil, and when that's parallel with the coil, and it softens that spike. It gives that spike somewhere to go, but they put a resistor in there. That's why you'll see a resistor in a relay. This switch right here, you might notice, is normally closed, and that was normally open, and these are kind of, now that right there, these are kind of wired in series, but that right there tells you that it was coming from another page. And if you want to see where that comes from, you go to the other page, and I think if you go back to the previous page, you'd see where that A is. See, there's B going to another page right there. Here's A, see that? That's the one right here, and that's when you're going to find out where that actually went when it left the page. You feel like it's going into a parallel universe. Something else that's really cool on these GM ones, I haven't seen this on any other one, it's really this friendly. These connectors are different colors. C1, C2, C3, and C4. Blue, red, clear, and black. You can absolutely tell if you're looking at one of these what your color of that is, and so you'll know exactly you're on the right connector. So remember that too. And so, in other words, if this is C4, pin 7. See, that's really important to know that too. All right, now this is what it looks like on a Ford. You're looking at the same thing. You're looking at your blower motor and AC stuff. There's your blower motor resistor. It's shown in all of its glory right there. You're only seeing part of the AC control head assembly because you got dotted lines here. Whenever you see a dotted ground, that means that ground's going somewhere, but it's not telling you where it's going. This comes from instrument illumination, and there's your AC control. So see that you got your blower motor switch right there. It looks similar to the other one. I'll be glad when he stops beating on that. Blower motor relays right here. Now look at this. What do you notice about the blower motor? It's got power all the time, and the various different speeds are controlled by this switch by providing a ground to the motor. So this is hot all the time. So you're basically going to see your voltage is being dropped on the ground side. You see that, and you also might notice too that this doesn't, I mean, whenever you turn the AC off, you don't have any ground being fed to the blower. That's why your blower won't work when your AC's off. And of course you see a fuse up here. That's basically what a fuse is. What's this right here? Anybody tell me what that is? When it comes to a symbol, that's a symbol. It's there for a reason. Get the idea? That's a circuit breaker, okay? When you see that, that's a circuit breaker, and sometimes you'll see this up in one of these places. That's your little silver box that goes where a fuse goes. Just remember what a circuit breaker looks like. All right, and then there's a little, another little shot at that. You remember the little clamping resistor I told you about it in the relay? A clutch, AC clutch clamping diode there. When the power comes in, it cannot go through that diode. You remember we had a diode on that board, right? It can't go through that diode, but it can go through here. And then whenever you turn this off, that actually causes that spike that would go screaming back through there to chase its tail. Now there was this, I think I've told about this a time or two before, but this Daleville Cablevision truck that had an AC style compressor clutch driving the power takeoff for the hydraulics for the bucket. They just put that AC style compressor clutch on there and put a switch on there, and the way they wired it up, it didn't have one of these clamping diodes on it. When they switch it off, it would send a 400-volt spike scraping through the wire harness into the radio. And it destroyed the radio. And they put another radio, and it destroyed that radio. Every time they turned it off, it was spiking it. I got my oscilloscope and hooked up in there where the radio was, because the radio kept dying. It was a brand new truck. And I started flipping stuff off and on that they had installed. And when I flipped that thing off, I saw that spike going into the radio. All I had to do to fix it was put a clamping diode in there. Bought one at Radio Shack, popped it in there, took care of that problem forever. Now there's your relay coil. Now you notice this one here is not even drawn with that resistor. They just don't always put it on the schematic, but it's in every relay that I've ever seen. When you take them apart, you'll see one. And you notice these switches are wired in series right here. So if either one of these switches opens, it's going to cause the same thing to happen. The PCM is monitoring that on pin 88. Now if you're ever in a situation where you're trying to figure out, what if somebody cut that wire or something? And you're saying, well, my AC's not working. So I'm going to go to pin 88. I should see a ground here when everything's at rest. Pretty simple how you do that. Remember, that little dotted line means all those are going through the same connector shell, and that dotted box means you're not seeing the whole thing. Nobody better miss any of those questions. On a Dodge, this is what it looks like. I think the the schematics on these Dodges and stuff are drawn by computers or something. Because this right here, when you go to work on a Dodge, you're going to have a page flipping odyssey. I'm telling you, it's going to go from one page to another to another. I was looking at this this 03 Jeep Wrangler that had dash lights not working, and in order to trace that current path for those lights, it were 7 pages of schematics I had to go through, which is totally ridiculous. I don't want to do that. But you notice right here, there's your coil, there's your little resistor I was talking about. Also, look at the similarities here. The AC low and high pressure switches, see that from your AC heater control? They're actually going through these 2 switches in series. Either one of those switches opens, you got nothing. There's your compressor clutch. Now you notice the compressor clutch on there doesn't go to the trouble to show that diode, but occasionally they'll build the diode into the darn thing. Now there's a fuse. See, the fuses look slightly different on that, but you still got dotted boxes because you're not seeing the whole thing. You got a solid box because you are. Then you got all these switch positions. Now notice what they do with these switch positions. they basically give you these numbers because they ain't got room for all this stuff in the box. They just put the numbers in there and they tell you what each numbered position does. Look at the difference in the way the grounds are drawn. The ground is nothing more than just a little splice with a line on it. Now on your Mazdas, and I think I got one of these farther down the line, you'll actually see a picture of the car body over there and a line drawn out here showing you the body ground. There's your blower resistor block. Now notice that. So basically your blower resistor block, and look at your, where's your blower at? Am I missing the blower somewhere? Where am I seeing that? I don't see the blower on that schematic. Let me see if I've got it on the next one. Nope, I left it off. But it's basically doing the same thing. You see you got the ground right here, and it's basically providing the ground to the blower motor. I left the blower out of that one. That was poor. I should have done better than that. This is what a Toyota schematic looks like. Now you see that little thing right there? It looks like a diode, but it's got little arrows pointing off of it. What does that mean, Mr. I'm playing with my phone? What does that mean? What do the little arrows mean is coming up? This is going to help you with your electrical final because everything is we're talking about. I got to beat this into your head so you don't forget it. It's really annoying when I go over this and over it and over it and over it and over it. I just only miss a question on the final, right? That little thing right there, what does that mean? Now that's a diode, that's a diode, that's a diode, that's a resistor. What does that little arrows mean? Anybody know? You ever seen that on a schematic? That is a light emitting diode, an LED. You know what an LED? This is an LED. That's an LED right there that's shining. See it? Whenever you see the little LED on the dash that comes on when you turn on your AC or something, or you sit on the dash and all that. All right, so make sure that you know that when you see that, those two arrows coming off of a diode, that's going to be an LED. And it also, on an LED, if you got one in your hand, it's got a little LED, the long lead is positive on an LED, and you have to have a resistor wired in series with it, or you'll burn the little sucker up as soon as you turn it on. Now look at your blower switch. See how they do that? Isn't that really strange? There's your blower resistor. See the differences in those? Now the grounds, you can see them how they're drawn down here. That's a joint connector, they call it. And look at the relay. The relay is a little bitty thing. Now you got a 10 amp fuse, and you got a little big fuse here. There's a 100 amp fuse. Be aware of the fact that when you see one of these 80 or 100 amp fuses in the panel, you don't just pull it out of there. You got to undo some bolts to get it out, or you'll bust something. I've seen people grab them with pliers, just tear them all to pieces trying to get them out of there. But they've actually got bolts because they got to have more than just a. They don't want to just plug them in because that has a tendency to get hot and burn things up. So they put them in there with bolts. They look just like all the other fuses, but if you look down on the side, you got to loosen a couple of screws or bolts to get them out. Yeah, so don't fall into that trap right there. Now look at this switch right here. Notice how that's two switches built together that are wired in series. See that? And so just keep that. Now one of the things Toyota does that's pretty cool is they actually show you the color of the wire the way it is in the real world. You see, and that's really pretty interesting too, the way that they go about doing that. That's a transistor. Remember that? See how that little thing looks? That little engine control model's got a transistor in there. And a lot of these ACs on these Toyotas and stuff have got a little AC amplifier thing that makes decisions whenever, you know, about the air conditioner. This is a Nissan schematic. This right here, a thermistor. What does a thermistor do? It changes resistance with temperature, right? And so basically it measures. And there's your thermal control amplifier. It's got a transistor built into it. I want you to be able to look at this. There's your thermal protector. If you get too hot, it opens up. There's your IEC, solenoid valve, air conditioner relay. See the difference in a relay on a Nissan, the way it's drawn? It just got, they don't even have a little dotted line there or nothing, but you got to be able to recognize that in the relay. And there's your switch, air conditioner switch, got a little bulb in there. They didn't draw it that way, but heck, that may be an LED. There's your fan resistor. Look at that funky switch there. See the way that switch is drawn? Is that mighty peculiar or what? Ignition on, switch on, you got the, look at the fuses. They don't look like the fuses on the other schematics, do they? But you got to be able to recognize that when you're going from schematic to schematic to schematic. Now the people that are the people that are handicapped, and I was kind of like this for years when I worked at if you're working at the dealership and they don't ever service anything but one particular kind of car, then you get used to that, the schematics and stuff on that particular car, and you'll be lost looking at somebody else's schematic if it's a lot different. All right, so let's go here. Volkswagen. Oh, you're going to love these. These are track diagrams, and they are really strange. Now, they make sense to the people who use them every day, but if you don't use track diagrams every day, basically the track is going to be like that circuit track right there, and they're going to show it going, you know, they'll show you the other track it turns up on. This is a wacky thing. I guess the German folks came up with it. And they're really smart, but they don't think the way that we do. You know what I'm saying? So they draw their schematics a different way. And if you ever go into the scan tool on a Volkswagen, you're going to see funky measuring blocks and all this kind of stuff that you're not accustomed to. And, all right, try to stay awake. I know this is, oh, and look at this. Your wiring colors are really good too. Look at this. You notice you got WS, SW, RO, BR. Some of them you figure out green, blue, gray. But look at that. SW is black. You got to be able to remember that SW is black. You expect to see a B for black, but in German, Schwarz is black. So that's what I said. That's why I got that thing right over there on the wall. And so be prepared for that. So if you're used to looking at your wire colors, also, I want you to see this too. You see how that says 0.5, 0.5, 4.0, 6.0, 0.35. That are the metric wire sizes. When you see metric wire sizes, that's how big that wire is in millimeters. That's on your test too. That's how big it is in millimeters. 0.5 is a half a millimeter thick. So if you're looking at American wire sizes, you know, or imperial, you're actually, the smaller the number, which way does the wire go?
Bigger.
Bigger. But a smaller a number on metric wire sizes, the wire is smaller. A 1/0 wire is going to be 1 millimeter, 5/0 wire is going to be 5 millimeters. But on the gauges, 8 gauge is smaller wire than a, you know, than a 6 gauge. And the lower you go. As a matter of fact, I thought it was kind of funny when you get these big battery terminals like on trucks, they have alt, double alt, triple alt. You know, they go bigger and bigger on that. All right, BMW. BMW you'd think would be more like Volkswagen than this, but see, they got this funky schematic right here. Well, you can recognize a ground. That's a transistor. That's a little resistor right there. There's, you know, this basically tells you it's a transistorized box. Transmission control module. It's got a little resistor in it where it's measuring something there. There's your compressor control relay. And you got to see how that relay is a big old long looking thing, but it ain't that big in the real world. And you got a dotted, same connector here. You're not seeing the whole box. The same rules are going to be applying on that. That's pretty good stuff there. All right, so here's Mazda. Now Mazda looks a little different from everybody else. Now, back in the day, they used to have a picture of the car right here. The car body, just like a little picture of a nondescript car body, which is pretty interesting. This is a thermal limiter, which is actually like a circuit breaker. If the blower is, like let's say the wheel came loose on the blower and it ain't moving in the air anymore, this is in the airstream on all these vehicles. Then if there's no air blowing through there, but there's current still flowing and these resistors get really hot, they got to get red hot and try to set something on fire. There was this lady one day that was beside the road, and her little Explorer, and I just kind of pulled over when I was on the way to, over to Savannah, and I stopped and got out there and said, "What's going on with the Explorer?" And there was 6 or 8 guys standing out there in front of the Explorer trying to figure out what was going on under the hood. She says, "Well, a bunch of smoke come out of my register and all," and so I opened the door and I smelled it, and it smelled like burning leaves. I said, "You're running your blower on low, I see," and there got your thing. Says, "What you need to do is just turn your blower off and go somewhere where your friend can take the blower resistor out and get the leaves off of it." All that was wrong with it was she was trying to set fire to the leaves. Even if there's air blowing through there, them resistors still get really hot and they'll set fire to some leaves. But she really didn't have as much of a problem as she thought she had. But when smoke starts coming out of there, it feels like the truck's going to be on fire in a minute. You know, don't run it on low. If you're running it on high, it wouldn't work, because why? You're bypassing the resistor, right? Okay, but anyway, look here. You got your blower resistor here. You got your blower switch there. And this right here is your mode switch on all that. See, I tried to do this on air conditioning so you see. This right here is a connector. Connector X02 is going to find, that's how you find your connector. And there will be a sort of a picture on there that's got a picture of the body of the car, and it's going to show you where all these connectors are. That's typically how that works. Look at those teeny tiny fuses right there. You got to be able to figure that out too. This is really important to be able to locate those. There's your battery. See, they got the batteries all kind of small too. Your blower motor's here, and so on and so forth. Anyway, the long and the short of it is everything's going through the thermal limiter except when you're on high. And you notice high basically it bypasses that resistor and goes right there. And your blower motor relay on that one powers it up too, and you're also providing a ground coming in from the bottom of the blower motor. All right, here's your Honda. Now Honda looks kind of like a Ford, a little bit, doesn't it? Favors it some. They didn't put that little clamping resistor in there. Your pressure switch, low and high, can go either way on that one, you see. Basically, your evaporator temperature sensor, that thing goes bad, you got no AC. There's your compressor clutch and your thermal protector. You see, that's a common little thing that they put on there. And there's your fuses. This is basically, they're nice enough to tell you what else these fuses do. Heater AC relay fuse. This one here, you got backup, radio, so on and so forth, and all that. And so that says 97 model there. But now, as you go through different year models, these schematics are going to evolve, so you're going to see some slight differences. So just be prepared for that. Look at Kia. Kia's an interesting thing. AC cut relay, they call it. You notice that relay's actually got a diode in it, not just a resistor. Then you got this one right here. You notice the similarities there? This is basically, these are wired in series so that either one of them can kill it. And there's your condenser fan motor, which is 1 hour behind the radiator, and so on and so forth. And there's your little ground. What's the common denominator here? You got your powering up the blower motor, and you're running a ground to it through the resistors. See that? You know, a lot of times we don't think about that, but most of these units actually are going to control on the ground side. Now, when you open or close a switch on the ground side of a circuit, it does not make as much of a spark as it does whenever you open and close the hot side. You got it? That's why a lot of the time you'll see stuff switched on the ground side, because the switch can, you know, is less likely to fail, because of whenever the points in a distributor open, that's on the negative side, unless you're talking about the stuff that Nick and them use on their race cars, that MDS ignition, it actually breaks the positive side, right? But on the ground side, if it's breaking those points, it's going to make a little arc every time. The condenser is there for a couple of reasons. One of the reasons it's there so that you don't have much of a spark, makes the points last longer. But it also helps charge up the coil better for the next pop. But anyway, they're breaking the ground side because it doesn't make as much of a spark. And see, there you got your actuators and all that. Here's Subaru. Look at this funky Subaru stuff. You got a blower motor relay here. See them strange relays, the way they draw them? But if you get to where you're understanding it, one of the things I like about some of these Asians is they'll take the connectors down here with the pin numbers and all, so that you'll know what the connector looks like, which pin is what and all that, because they know you're going to need to know this stuff. Now you see that connector right there, F24? That's F24 right there. You see B10, there's B10. They tell you pin 1 and pin 2 right there. You can see how it's wired up. When you're looking into the connector, you know which one is which. That's really good. You need to know that. If you ever worked on wiring, you'll know that that's an important thing. They also are sweet enough to tell you the color of the connector. Ain't that nice? Blue, gray, brown. I mean, they're wanting you to be able to fix their car by looking at their schematic, right? But you can get an idea of the similarities between all that air conditioning relay. It's got, you know, it's got 4 terminals like you'd expect and all that. There's your thermal protector. There's your magnet clutch. See the AC compressor clutch, how much different it looks on this one? You better be able to look at that and sort that out in your mind. That's one of the things we got to be able to do. There's your Hyundai. You know, you're seeing the same thing. That's a transistor. And that one right there is a PNP, but I mean, I'm sorry, an NPN, because you got negative feeding in there. Then you know the power, the P, is actually what's going to trigger that to close, like we showed you on the console board. There's your AC relay. Notice they're not showing the little clamp resistor. There's a fuse. After a while, you'll get to where you're used to this. The dotted box, see how a lot of the rules are the same, and the line showing that you're in the same connector. And there's your dash fuse box, tells you that. And you got your blower resistor. It's basically got fuses in here. That's like they got that drawn as a fuse, but it's a thermal fuse basically is what it is. And I can show you what one of those looks like, so that if it's not blowing any air through there because your blower motor lost its wheel or whatever, but it's still employing current. Look at your compressor. See how that looks different on that one? They're showing you that it's grounded to the frame. There's a diode, and that diode is basically there to keep that spike from happening. There's your pressure switch and thermostatic switch to keep the compressor running. That's keeps the evaporator from freezing up, what that's for on all of them. And there's your AC switch. There's a little solenoid in there and all that funky stuff. But you can kind of see that happening. Now, what you need to get done, get your worksheets, you get your live work jobs, you go to your electude. This gives you interactive theory training you can't get anywhere else. This gives you real world repair. They teach you things you didn't know to make you better at things you've already done. This one, the guy that's on our board now that owns a chain of these dealerships around here, he was telling the president of the college, he said, I've got some of your people working for me, people that I've trained that have gone to work at him. And he said, some of my mechanics are making $100,000 a year. And that's right around here. That's not in Atlanta, Montgomery, Birmingham, and they make more of it that way. So what I'm saying is, there's a dwindling pool of people that know how to do this kind of work. And if you get up there and you start doing this and you get good at it, or they respect you and they throw you the right kind of work and you can knock it out quick, you're going to make you some money. Now, if you're not interested in working hard, you see that little thing I posted on Facebook, and Thomas Edison says most people miss opportunities because it goes around in overalls looking like hard work. You know? And finally, the last slide of the day. I haven't done anything all semester, but what can I do in the next 5 minutes to bring my grade up? We have the slide.
That's pretty good.
Yeah, you like that? I mean, that's one of the things that I have actually had students that did that. You know, they didn't do anything all semester long, and they hope right at the last week they can slide in there and maybe get a passing grade, even though they learned not a dadgum thing all semester long. There's one guy years ago, he missed I don't know how many days of class, and he came out there, and I was sitting on about the coffee table, and he said, what can I do between now and Wednesday? This was like, you know, Monday afternoon, you know, to pull up all these F's that I have in all of my courses. And I said, you failed. You've already failed. You can't do anything to fix it in 2 days. You know what I mean? Just get used to the notion that you failed, because this is one, that's like this guy right here. Every instructor that's ever taught a college class has had this. You know, no matter what discipline you're teaching, I don't care if it's nursing or computers or whatever, everybody's already had that. So. Okay. Now, did y'all have a good time today? Did you almost go to sleep? The person that's not likely to go to sleep is the person that's doing all the talking, and that would be me, right? All right. So everybody knows what you need to do to survive this semester, right? If you and you know some of the worksheets, you know, if you're in doubt about a worksheet or don't know, you know, what you need to do, just let me know and I'll point you in the right direction and all that. And Charles out there is he's been beating his brains out on live work all semester long. He's completed a ton of worksheets, just busting his rear end on his live work. You know, and he was concerned about that. I said, your worksheets are going to be just fine because you've worked your, you know, Tim, you know, works about as hard as Charles does. Well, he's a lot more methodical, you know. The guy on the Jeep said something about the wall light came on or whatever. And I told him, I says, you can bring it for us to look at, but realize that you need to check the wall. I don't know what's going on. He didn't bring it for an wall light before. You know, and we put valve cover gaskets on it. What in the Sam Hill he's talking about a wall light for? I don't get that. Unless there's a wire that's touching or something somewhere. But anyway, I said, you know, we ain't got a lot of time. We're coming up on the end of the semester, so be aware of that, you know, and everything. So that's one of these. He didn't, I mean, I figured it would be out here when I got here, but he didn't show it up, you know.